Hi, folks. My name is Ms. Midha, and today we're going to focus on the following question. How do we define the union and intersection of two events? So let's get started. All right, here is our first situation for the day. A bag contains 3 red marbles and 1 blue marble. Sally draws from the bag twice and replaces the marble each time. All right, we've got 2 questions to answer pertaining to this scenario. First question, what does it mean that Sally replaces the marble each time? And then, what would it mean if Sally does not replace the marble each time? So I'm going to ask you to pause the video and take as long as you need and see if you can answer these 2 questions, given the situation, given that tree diagram as well. Once you think you have the answers, go ahead and unpause the video and we will review. All right, so what does it mean that Sally replaces the marble each time? Well, if you notice that when the situation starts, when the scenario starts, there are 4 marbles in total, right? I know this because it's saying that there are 3 red marbles and 1 blue marble. So there's 4 marbles. So after the first draw, Sally takes one of the marbles out, but she replaces it. So she puts it back in the bag. So that means even on the second draw, there continues to be 4 marbles in that bag. So if she's replacing the marble, she takes one out after the first draw, but puts it back before she takes one out for that second draw. Now, what would it mean if Sally does not replace the marble each time? Well, exactly as it sounds, right? After taking one marble out from that first draw, she's not going to put that marble back. So that would mean for that first draw, she has 4 marbles to choose from. Once she takes that marble out, she's not going to replace it. So for that second draw, she has only 3 marbles to choose from. Okay, now use that second question. Keep that second question in the back of your mind because we're going to be looking at this for our next scenario. So here goes. The scenario has changed. A bag contains 3 red marbles and 1 blue marble. Sally draws from the bag twice and does not replace any marbles now. So we've got some questions pertaining to this scenario as well. First, you want to fill in those boxes with the appropriate probability of drawing red and blue marbles on the second draw. Then you want to figure out which gives a better chance of drawing a red marble on the second draw, replacing or not replacing the marble. Once again, I'm going to ask you to pause the video. Once you think you have these done, unpause and we'll continue. Okay, now in order to fill in these boxes, we really need to remind ourselves how, this whole tree diagram is working. So you'll notice that that 3/4 and the 1/4 has to do with the first draw, right? There is a probability of 3/4 such that a red will be chosen on the first draw. There is a probability of 1/4 such that a blue will be chosen on the first draw. After those first draws have happened, then we are branching this tree diagram or this tree out a little bit further, right? So I'm going to focus on the top half of this tree diagram for right now. I'm just going to split it in half so we can see what I'm referring to. I'm going to just think about the second draw after that first draw has already happened, such that that draw was a red. So let's think this through. After the first draw has happened, such that the first draw was a red, what is the probability of drawing another red? Well, let's keep the idea in mind that Sally does not replace any marbles now. So because she's not replacing any marbles, let's think this through. Because she's not replacing any marbles, how many marbles remain in that bag? We started with 4. She took one out. She's not replacing it. So that means there's only 3 marbles left. So now I know that the denominator here has to be 3. Okay, now what's the probability that this draw will be red? Well, because our first draw was a red, right? Notice the direction that I'm working in here. Because our first draw was a red, she did not replace that red, right? And we started with 3. That means there are only 2 red marbles left. So that means the probability here will be 2 out of 3. Okay, now what about blue? What is the probability such that the second draw will be a blue? Okay, again, the first draw was a red. She does not replace that red marble back. She does not put the red marble back into the bag. So we know we have 3 marbles to choose from. How many are blue? There's only 1 that's blue, and it was not taken out on the first draw. So that tells us that the probability of getting a blue on the second draw will be 1/3. Okay, now for the second half. I'm just going to erase this right here so we can focus on the second half. Now notice that we are looking at the probability for the second draw such that the first draw was red. So now let's think this through. If my first draw was blue, and I'm actually going to go blue first for my second draw, if that makes sense. If my first draw was blue, what's the probability that my second draw will be blue? Again, I'm not replacing. So if I've got a blue on the first draw, and I'm not replacing that marble, I know that I have only 3 marbles to choose from. My first draw was blue, and I didn't put it back. How many blues are left? There are none. There are none, so this is actually 0. All right, what about the probability of choosing a red? Again, the first draw was blue. I'm not replacing that blue marble back. I'm not putting it back in the bag. So I know I have only 3 marbles to choose from. How many of those 3 marbles are red? Well, if we've taken 1 blue marble out, we're only left with 3 red marbles. So that means our probability here is actually 3 out of 3. So using that information, let's look at that second question. Which gives a better chance of drawing a red marble on the second draw? Replacing or not replacing the marble? So if I look at that tree diagram, it actually turns out that not replacing the marble will actually give us a better chance of drawing a red marble, right? Because notice what's happening here. We have a probability of 3 out of 3 now of actually getting a red marble on the second draw. All we care about right now is that second draw. And which one gives us a better chance of drawing a red marble on the second draw? Not replacing the marble. And you can further prove this by looking back at the previous slide when we were looking at the tree diagram that was replacing the marble. Okay, we are going to keep moving. We have one more scenario to look at, so here we go. Okay, now we have a bag of marbles again. This time it contains 3 blue marbles, 4 red marbles, and 2 yellow marbles. So we're going to find the probability of a couple of different scenarios here. We're going to first find the probability of 2 blue marbles drawn in a row without replacement, 3 red marbles drawn in a row without replacement, and then finally a red marble drawn first, a yellow marble second, and a red marble third with replacement. So one more time, I'm going to ask you to pause the video and take as long as you need to answer these 3 questions. Once you think you have the answers to everything, you can unpause and we'll review. Okay, so what is the probability of 2 blue marbles drawn in a row without replacement? All right, well, let's take a look. How many blue marbles are there? I can see from the visual that there are, in fact, 3 blue marbles. Okay, and I'm just focusing on my first draw. My first draw, there are 3 blue marbles out of how many marbles? Well, I can see there is a total of 9 marbles. So that means the probability of getting a blue on the first draw is 3 out of 9. Now, we are not replacing that blue marble back in. So I'm going to go ahead and just cross one of these marbles out. It no longer exists in the bag, right? We've taken it out. We have not replaced it. We've not put it back. So now, what is the probability of getting a blue marble on the second draw? Well, how many blue marbles are left? There's only 2 blue marbles. Out of how many total marbles in the bag now? Because we took that 1 marble out, there's now only 8 marbles left. So we know that the probability of getting a blue on the second draw will be 2 out of 8. Now we are not done because we need to figure out the probability of 2 blue marbles drawn in a row. So this is like saying, what is the probability of drawing a blue and a blue, right? A probability of 1 blue and another blue. Now remember, what do we do when we hear that word and? This is essentially looking at the union of 2 events. And whenever we hear that word and, whenever we think about union and probability, we want to multiply these 2 fractions together. When you do that, you're going to end up with 6 over 72, and this could be further reduced to 1/12. Excuse me. So the probability of 2 marbles drawn in a row without replacement, 6 over 72, simplified is 1/12. Okay, now what about the second example? What is the probability such that 3 red marbles drawn in a row, or what is the probability of 3 red marbles drawn in a row without replacement? So here's the without replacement again, okay? So it's the same exact idea. I'm gonna go ahead and erase this little cross out so we can think about the reds now. Okay, how many red marbles are there? Well, I can tell from the visual there are in fact 4 red marbles. We know that there are 9 in total. And now we are not replacing that red marble. Again, without replacement. So I'm going to cross one of those red marbles out. I'm going to ask the same question. How many red marbles do we now have in the bag? We have 3. Out of how many total marbles? Well, we've got 8 now. All right, I'm going to take one more red marble out. All right, again, we're not replacing it. We've taken one in the first draw, another in a second draw. How many red marbles are left? I can see there are 2 red marbles left. Out of a possible how many marbles? Well, now I just have 7 marbles. Okay, just like the first problem, we're not done though, right? Because again, this is a union. It's a union of 3 different events, if you will. What's the probability of a red and a red and a red? Keyword and. What do we do when we hear the word and in probability? We multiply. Okay, so when you multiply these 3 fractions, you should get 24 over 504. And you may have simplified it earlier on, or you simplify it now. Once you simplify it, you will get a final answer of 1 over 21. So the probability of 3 red marbles drawn in a row without replacement is 1 over 21. Okay, last question. A red marble drawn first, a yellow marble drawn second, and a red marble drawn third with replacement. So because it says with replacement, we know we're going to have 9 marbles in that bag all the time. So what's the probability of a red marble being drawn first? Again, I know that's 4 out of 9. I'm not going to cross out a red because I'm going to put it back. So what is the probability of a yellow marble being drawn second? I can see that's 2 out of 9. 2 yellow marbles out of a possible 9. And then finally, a red marble drawn third. Well, again, I still have 4 red marbles in there because I've replaced that first one. So I'm going to have 4 out of 9. Okay, so again, a red marble and a yellow marble and a red marble. What do I do with these 3 fractions? I multiply them together. Now, again, you could simplify this early on. If you don't, if you multiply just across numerator times numerator times numerator over denominator times denominator times denominator, you end up with an answer of 1632 over 729. Actually, you can't simplify this one further, so that is the answer. Okay, so to recap, what have we done? We've looked at a couple of different scenarios, some involving replacement, some involving without replacement, and we determined the probability of different situations given those scenarios.